Welcome. This is part 3 of the vRealize Operations webinar series that we're doing this year. Today we're covering capacity planning, Demystified. Sunny will be doing the lab a little bit later on. So this will be kind of a 50-50 presentation. I will cover sort of the introduction to capacity planning, fundamentals, the phrasing, the words that are used, with like any product. They've got their own specific terminology, and it's good to get your head wrapped around that. So if we move forward in the text. All right, so we'll do some housekeeping now. We're going to try and keep the question and answers to the end. So if you've got a burning question, if you could type it in to me or Sonny, but preferably myself because he'll be hosting the lab. We will endeavour to answer it either at the end of the session or at a suitable time that I can interrupt Sonny. The session is getting recorded. We'll post it up. That'll be in the next couple of days. We'll post links on that. So if you want a recording or want to view it on YouTube and that, just keep your ears to the ground, or if you want, send us an email and we will get back to you. Any technical issues, you can see there Sonny's email address, and we would love your feedback. Okay, let's move on. Okay, so I'm Simon Eady. I work as a senior consultant for a company called Extrovert in the UK. Really enjoy using vRops. Sonny, my partner in crime today, he's well-known VMware employee there, very, very good with vCops and vRops. We both put this idea up of a webinar. I won't linger up too long on the whys and the wherefores, but this is who we are. If we move forward. There we go. Okay, so what are we going to cover today? Well, we're going to cover what actually is capacity planning. How can vRops do that for us? How does it do it? What are the elements that are critical to that? The terminology used. We'll jump over to the lab. I'll have a Q&A at the end. We may sidetrack a little bit depending on where we go, but that's the general overall subject matter. If there's anything in there that we cover that doesn't cover anything that you're particularly interested in pertinent to capacity planning, again, just send us a question and we'll try to answer it for you. Okay, let's get on with the first slide then. So what's capacity planning? Well, I'm not going to read that out on there, but as you can see, it's all about managing your infrastructure, making sure that what you have is enough, but also not what you have now is enough, but also what you have in future is enough. As infrastructure managers or members of operations teams and so on, it's crucial that we size things correctly, that we have control of it, that, with virtualization these days, you want to perhaps overcommit, or perhaps you don't want to, maybe you want to undercommit. But you need a way and visibility of doing that. You need tools to achieve that. If you want to look at your CPU and memory or storage, or you're looking at future projects or new hardware, this is what it's all about. Let's move forward. So how can vRops help? Well, current questions or common questions. How can I use, so I've got current usage, how long have I got before my existing cluster or clusters or data center, depending on your business or your size, how long before I run out of capacity? When you're thinking in a business case, it might be that you have a fixed budget per year or every 2 or 3 years, depending on your refresh cycles. You want to know if you've got developers going crazy in terms of needing to provision more and more because business is good. You need to be able to go to your manager or CIO, CEO and say, look, we're doing great here, but the cluster here is going to run out of capacity in X time, and here's the data. So that a really compelling business case and use case for this. You want to know how much capacity have you got remaining. Or how much capacity do I need to satisfy current demand? It might be that you're already running very, very hot. And, maybe the development team are going, hey, guys, we know you've given us everything we've got. We still need more. you can use, as we'll cover a little bit later, projects. So you can put in there and say, right, we're going to provision another 100 or 200 VMs doing X, Y, and Z. This is the average size of the various VMs. What do we need to go and buy to provision this, and maybe a little bit extra for overhead. How much capacity and resources am I wasting? So this is looking at it in a completely different way. This is where you're looking at things like right-sizing VMs, running reports to say, hang on a minute, Mr. Developer there's provisioned a 16 CPU VM. I'm sure you've all come across this from time to time where someone's hilariously over-provisioned a VM in your environment or several VMs in your environment. You can see co-stopping going on or not. You can see CPU ready going through the roof, and you're having to track it back. And then you make a challenge and say, hang on, look, you don't really need these resources, and you've got a report there to say, no, guys, you are massively over-provisioning this, and you don't want to waste your very expensive hardware that you have in your data center. Okay, let's move forward. So how does it do it? Okay, so with vRops, you've got vSphere limits. You can show better how the capacity is available. The capacity calculations, you've got badges and metrics. Everything's calculated every 24 hours. Time remaining, badges and screens. I'm not going to read all this stuff off the top because we want to get through this and get through to the lab. But you can see there's lots of improvements have been made to make life very much easier for you in your capacity planning needs. Let's move forward.
Yep. As we move forward, I mean, it's important to understand, and Simon, what we see day in, day out, right? As consultants, we go to the customer's place, and I think the single biggest question which they always have, especially if they've done the first phase of virtualization, is that I really do not know when will I run out of capacity. It was easier when it was physical because I have one app mapped to one physical server. But now you're asking me to virtualize, and it's next to impossible to figure out when will I have capacity on a given cluster, given that vCenter or other tools which you use for monitoring don't have those capabilities. So that's where vRops plays a big role. And as Simon mentioned, we'll probably go ahead and try to just demystify some of the options available within the tool to help you understand capacity day in, day out, and then build on that, because it's important that you build a process around that, as Simon mentioned, that it cannot be just numbers, but you need to also understand that how you plan your capacity, at the same time how you reclaim capacity so that you can save on dollars and reuse it within your infrastructure.
Mm-hmm. So, I mean, vRops is a great tool for this. Many of you may be aware that this is a strength that's been even carried over from vCops. So you may have been a long-term customer of VMware. You might have had vCops for a long time, and that was one of the key selling points or key product features of vCops, to be able to do this capacity planning. And vRops has just taken it and raised the bar even further. And with 6.1, there was an introduction of a feature. Sorry, go ahead, Nick.
Mm-hmm. Yeah, Simon, I was just saying that, in fact, it goes back beyond vCops, right? It was Capacity IQ, which was the product to begin with. And then we rolled in the features of Capacity IQ into vCops, and now it's in vRops. And the great thing is that earlier it was just limited to virtual machines, and today it can do capacity planning for anything what it's feeding on. So if you're sending any data to vCops, it can do capacity planning for you based on trends and forecasts. So now it considers that every citizen is a first-class citizen, so which is an awesome thing. And,
very.
And as we move forward, we'll look into those use cases as well.
Yeah. Okay, let's move along. Okay, so policies are critical to this. So anyone using vRops, even if you're new, you should be aware that policies are intrinsic to the success of your vRops deployment. So let's look at how policies are critical. Everybody's environment is different. So your policies, you'll have lots of out-of-the-box policies. You may have chosen to use them just to get started, which would be quite a sensible approach. and then starting to tweak them after a period of time to suit your environment. These are absolutely critical to you. There is no, I say, wrong or right way to do it because your environment is unique. You will have different areas or silos of virtual machines or different clusters that will be doing different roles, whether they be production, pre-production, QA, test, development, all of these things. But you still need policies to cover those if you want effective reporting, because you don't want false positives. I won't linger too long on this, but we've covered policies a little bit in the previous session, but they are absolutely critical to the capacity planning that we need to do.
Yep.
Okay.
So as we move along, we'll probably this time deep dive into policies specific to capacity and see that how you can set up your policies to make sure that your capacity planning numbers are calculated as per your business requirements. So with that, I think we can move forward and talk about projects now. Go ahead, Simon.
Yeah.
I'll give this one to you.
Okay. Projects. So this is the cool new thing in 6.1. This was a commonly asked for thing for many, many years. I'm fairly certain Sonny will have heard this request more than me, where, you with vROps, if you're familiar with using that, you're doing your capacity planning with your team, and then once you've worked it all out and you've got the figures off the screen, once you've moved on from that window, that sort of, and I'll put this loosely, project that you were working on is gone. It's not saved. There was no way to keep that information. So if you were looking at saying, okay, we're going to add 6 new hosts, or we're going to introduce a new cluster, or actually we spin it the other way, the development team have got this big new project and they need to spin up another 100 VMs, or we're going to bring in a new Exchange cluster. Whatever it might be, there was no way to save that project or piece of information. But now you can. They're called projects. And with this, as you can see, you can have the events that they're modeled, total capacity and or usage. You can have timestamps on them. You can have, you can edit and save them. You can have multiple ones of them. So you can have, there are lots of ways you can use them to get what you need out of it. And it's a great way of again, going back to your boss and saying, right, we've done the maths. We want to look at introducing this hardware, or the dev team have come along. So if we're all guys who are working in infrastructure, we will have demands from them. As our customers, as we may want to call them, they are asking for more and more. So you can say, right, I want to be able to do this. I can't. I've run these plans. You can see how I've modeled them. They're accurate. This is the hardware I'm going to need. Please give me the money. This is where this kind of thing comes into its own. Okay, let's move on. So let's look at the terminology. Now, I don't really want to linger here too long, but it would be good for everybody to see how this works. So we'll have the deck up just for a little bit for you guys to digest. Lots of things there. There's always queries around what does reservation mean, or what does entitlement mean? What's the difference between demand and usage? All those kinds of things. It's there in black and white. This terminology is very important for you, especially when you're not when you're just doing capacity planning, but when you're zooming around in the risk charts and so on. You can see that this terminology is used. This is great to understand and help you understand if you're troubleshooting as well. But it's a great way of making sure that you have absolute clarity on what's being said and what it actually means.
And just to add to that, to what you mentioned, Simon, I think we have Ivan on the line, and we have contention out there. So he's the one who is the biggest advocate for that particular metric out there. So contention is very important, right? I just wanted to put a joke across to him. Okay. Yeah. So, I mean, as you mentioned, these capacity metrics are calculated 24 hours, or most of them in that matter, but they are the ones who actually help you to build your reports and dashboards around the entire capacity stuff. And to be honest, it's not easy to digest all the hundreds and hundreds of metrics which are available in vRops, but it's important that we highlight some of them and look closely into what they do. And I think mentioning Ivan and his book over here is very important. I've reviewed the first edition and the second edition as well, which is about to come out, and I've noticed that that has description and examples of how each and every metric works and how it is calculated, which is very, very critical information in my opinion. So that's something which we want to look at in terms of learning more about each and every metric out there on vROps.
Absolutely. All right, let's move forward.
Okay, I think it's the last time now. Okay, fantastic.
So I was going to say, just wanted to repeat what we said earlier. So while Sunny's doing the lab, if you have any questions during the lab, it would be great if you could put the questions in the chat window, and then I'll either interrupt Sunny at a suitable time, or we can raise it at the Q&A session. But don't worry, we will answer your questions. Okay.
Yep. All right. Fantastic. So this time around, we're not directly jumping into the lab because we want to set up some context around this. So this is capacity planning is not as simple as, there are these 4 features, you just go ahead and use them. So this time around, I'm actually talking about some real-life use cases which we face on a daily basis when we go to customers. And people on the call and people who will be listening to this recording later on, I believe as consultants or as admins or as capacity planners within your organization, you would basically get challenges from business in terms of what is the forecast of the business or what would be the demand in the coming future. And based on that, you need to do capacity planning. So it's important that like any other design, which you do for your architecture or for your infrastructure, it's important that you design your capacity planning based on the requirements as well. So let me just jump over to the next screen and show you some scenarios based on which we will do our lab today, right? And make it more meaningful in terms of what we are trying to solve as an issue from a customer perspective. So first thing first, we'll go ahead and look at the generic option in terms of understanding capacity and time remaining analysis, which is there in the system. So we'll basically look at what is available out of the box and how you can have a look into it. And then we will go into this case study. So let me just quickly go ahead and read this case study to you, and then we will get into the demo. So if you look at this, there is an organization that's trying to deploy vROps in their environment for performance and capacity planning. And in relation to capacity, they basically are looking for an appropriate policy to meet specific situations or specific use cases which they have in their business. If you look at it, they have 3 different environments within their virtual infrastructure. The first one is basically the one which runs their business critical applications, and they call it the tier 1 environment. And this environment basically runs around 20% of their workload. However, it generates around 80% of company's revenue. So it clearly means that this is critical to them, and they do not want any contention in this particular environment, right? They don't want the resources or the virtual machines to fight for resources, because that will end up applications seeing that impact from a performance standpoint, and it may end up into downtimes or slow performance, which they don't wish to see because that's their bread and butter from a business perspective. The second scenario is tier 2, which is this is the environment which usually is around 70% of most of the organization's application. And it's the same case with vExpress Inc., where they have web servers, Java applications, databases, SharePoint, internal servers, etc., which are running in their tier 2 environment. And this is where we basically run IT and some of the business applications which are not resource hungry or which might be supporting some internal functions within an organization. And that goes into the tier 2. They also have a tier 3 environment, and this is for test and development of applications. So this is basically a group of developers trying to do regression testing and building up new applications, destroying them, so on and so forth. And this environment, of course, with virtualization, there's a need to maximize the investments there and make sure that you can do more out of little, and hence the consolidation is basically the main focus over here from a virtualization perspective. So these are three different scenarios if you look at them. And as a consultant or as a person who's working on vROps, and if you want to design for these scenarios, you will immediately go to the drawing board and see that this is how the triangle, or this is how the applications of the organizations are stacked, right? You can see that the test and development is right there at the bottom of the triangle, while you have production apps in the middle and the tier one apps right on the top. And you can see that the chunk in most of the cases would also differ in terms of the sizes. So tier one apps will usually be the lower ones or lesser in numbers. However, they do most amount of revenue. Now, in vROps, if you actually need to go ahead and create specific policies for these different tiers, then you would have to go ahead and first use something called custom groups. And then those custom groups can be tied down to custom policies. So now, in this case, we will basically go ahead and have specific groups for each of these tiers. So you can see I have a tier 1 group, a tier 2 group, and a tier 3 group. And then we will have a tier 1 policy, tier 2 policy, and a tier 3 policy associated to each of these groups. And needless to say that each of this group will have specific settings, and each of these policies with tied to those groups will have specific settings based on the business requirements which we saw, right? And we will see this in a live environment as we move forward. So just to look at the steps in terms of how we will do it, we will first go ahead and identify the different tiers. Now, it's important to understand that every customer might have a different definition of their infrastructure tier. For some customers, they might dedicate clusters to each tier, where they say this X cluster is for tier 1 applications. But some might not be, that resourceful, or might not have so much of resources lying out there to dedicate clusters, and they might want to do everything with a single cluster. In that case, they will use resource pools. So that's where they can create multiple resource pools, and each resource pool will have a different setting in terms of how they go ahead and get resources from the underlying vSphere cluster from a reservation and a limit standpoint. They can also go ahead and group their applications based on folders, where they will go ahead and create specific folders for specific applications and group them together. So that's one way by which you can group things, right? Once you group them, you would basically create custom policies for each of these groups and attach them to individual groups. And that is something which we'll see during the demo. And then the last one, or the last two ones, are modifying the custom policies as per the requirements. So this is the important step. This is where we will deep dive and understand that how we can have specific set of changes to the policy so that it meets the original business requirement which we saw in the previous deck. Last but not the least, something which I practice and I tell people to practice as well, is to back up your policies. So once you create them, you back them up and keep them so that you can use them or reuse them. And every time you make changes to the policy, you back them up so that you always have a repository with you, and you can always import them back.
One thing, just wanted to jump in, something to reiterate that we've said before on previous webinars is avoid using the default policies. Always create or clone from the masters. If you start editing the default policies and so on, you'll find yourself in a little bit of bother. So it's good practice to always create your own. Don't utilize the masters.
Yep, unless you're doing a demo like me. So that's a different story. Right? Okay, so let's just jump back a couple of slides and look at where we need to start, right? So we need to start at understanding capacity and time remaining analysis, right? So let's look at what we have, and let me just quickly jump to the lab. And Simon, let me know when if you can see this.
Yeah, we're good. We can see that.
Okay, great. So I do want to shout out this time to Rawlinson, who is a friend and a colleague with VMware, because we wanted some real good capacity to show capacity numbers, right? So he helped me getting his lab, which is running somewhere in Washington, D.C., so that I can access that and showcase some real servers. And this guy is running vSAN out there. And for the record, this is vROps 6.1, which we are running right now in this particular lab. So let me just go ahead and show you what I have in my lab, and then I will also talk about the capacity analysis. Right, so if you look at this lab, I have a single cluster here. Let me just quickly get to that cluster for you. And you can see that I have 4 nodes in this particular cluster, and that's how we are looking at the data. So if you basically want to go ahead and look at the capacity numbers right out of the box, you basically need to go ahead and select a cluster or any of the other containers. I usually like to start with a cluster to look at capacity focusing to that particular cluster itself. And once you click on that, you can see that the focus changes to cluster here, and you can get the various different tabs which are available. So today we are focusing on capacity, so we'll just go ahead and look at the analysis tab. And if I click on the analysis tab within the vROps, I'll quickly go ahead and jump into the calculations which happen based on the policy. So you can see that I'm using the default policy over here, which is applying to this cluster, and I'm calculating everything over here, which is workload, anomalies, faults, etc., based on the default policy. Now, today our focus would be on capacity remaining and time remaining, and that is something which is built out of the box. So this is the out of the box page where you can go ahead and say, what is my capacity remaining on this cluster? So as soon as I click on that, it immediately gives me a nice score in terms of badge, in terms of what's my score in terms of remaining capacity. We can see that this badge score is based out of the percentage remaining capacity, which you can see right over here, this 36%. At the same time, you can see a clear breakup in terms of what this capacity is made up of. So if I scroll down, you can see that I have 4 different things which are configured in the policy based on which I can see the capacity. It is CPU, memory, disk space, and the vSphere configuration limit, which Simon spoke about before, which basically means that I will only give you configuration numbers which are supported by vSphere and not beyond that. Now, if we quickly focus on just CPU and break it down, you can see that I can do capacity planning based on 2 things. One is demand, and the other is allocation. Now, this is where it gets interesting. This is where you come to, or you have choices, right? What is demand and what is allocation? So I can probably explain it in a simpler term by telling you that demand is where you are measuring the actual utilization of your workloads, which are running in a given cluster or a given node or an ESX server. And allocation is where you are saying that I want to go ahead and configure my cluster based on a specific overcommitment ratio, which could be 1:1 if you don't want to overcommit, or it could be 16:1 if you want to overcommit. And when I say 1:1 or 16:1, I'm referring to CPU and memory over here specifically. And you can do that for disk space as well, by the way. So when I say CPU, how many virtual CPUs you want to run per core. And when I say memory, then you can do percentage-based or ratio-based overcommitment as well. Same goes with storage. So if you're planning to do thin provisioning is when you can start tweaking the numbers in the policy so that you can get overcommitment ratios out there. So just to give you an example, which you see on the screen, you can see that I am doing capacity planning both on the basis of demand and on the basis of allocation here. And you can clearly see that on the basis of allocation, I'm considering an overcommitment ratio of 4:1, which you can see right over here, which is configured in the policy, and that's why it's reflecting here. So today, if I go ahead and change that policy, that number would change as well. Now, within this, you can see that I have 192 vCPUs which are configured, and out of that 192 vCPUs, which is on the basis of 4:1 capacity planning, it means that I have 192 divided by 4 number of cores in my 4 physical servers, which I have here. Very important to know that this does not calculate or consider hyperthreading while calculating CPUs. So hyperthreading is not a part of vCOps or vROps capacity planning. So it's all based on the actual number of cores. Now, out of these 192 vCPUs, which are on the basis of 4:1 ratio or of overcommitment, I'm subtracting 10% buffer from there. So if a company or an organization doesn't want to go beyond 90% CPU usage or allocation, then they can basically set a buffer in the policy, and that buffer shows up over here. You can see that my HA buffer is 0%. This is again an option in the policy. So if you want to consider your HA buffer, which you should, then you basically go ahead and select that in the policy, and after that you will see some more buffer over here being saved for HA. And just to round up the calculation, if you have a 10% buffer, it'll basically tell you that you have 90% of the total which you can use, so that becomes your usable capacity, which is around 170 odd vCPUs, right? And then it comes to what is the peak value in terms of what you have configured at peak at any given point of time. And at the same time, you also get the recommended size in terms of what you can go ahead and allocate at a given point of time. And ultimately, at the end, what is the remaining vCPUs? So here you know that you can have 83 more vCPUs in this particular cluster based on your allocation ratio of 4:1. Okay, I'll stop here for you to digest this information. Now, this is on the basis of allocation, right? Similarly, you can do it on the basis of demand. Now, if you do it on the basis of demand, and if I just jump into this demand section, you can see that I'm looking at my 30 days demand to go ahead and figure out that what is my total usable capacity in terms of gigahertz. Now, remember, when you're talking about demand, you cannot talk about number of vCPUs because it clearly doesn't matter. What matters is that out of whatever CPUs or vCPUs you have, how much CPU power you are using on the basis of gigahertz, which is the actual utilization. And that's where demand comes into picture. And here you can see that we're talking about gigahertz usage. And out of that gigahertz usage, you see that I have not configured any buffer in this case. Hence, I can use 100% of whatever is available. So this 100 gigahertz is actually the physical capacity of my box. And out of that 100 gigahertz, I'm actually using, or the max I've used ever is around 28%, right? And the more, or the available remaining is around 71% of CPU power, which is around 71 gigahertz in this particular case. So that's how you basically decipher in terms of how much vCPU or how much CPU or memory you have been using, whether on the basis of allocation or on the basis of demand. Now, the good news is that this number over here, or the number of capacity remaining over here, will be the least or the lowest common denominator. So in case your CPU remaining on the basis of allocation is 50% and your CPU remaining on the basis of demand is 30%, then you will basically get that 30% over here if both allocation and demand are enabled in your policy. So it basically takes the least out of them. And then what it basically does is it uses those capacity numbers on the basis of CPU, memory, and creates virtual machines for you in terms of how many VMs are remaining. So at the end of the day, the capacity remaining becomes more meaningful when I tell you that you can do 20 more VMs. And it'll be excellent if I can tell you what would be the capacity or configuration of those 20 more new VMs, which can be seen here. So if you look at the screen, as soon as I click here, I see 5 large virtual machines, and within those 5 large virtual machines, as soon as I click on the little black triangle, I can see what is my profile on the basis of which I'm telling you that you can do 5 more large virtual machines, which is fantastic. The good news is that with 6.1 and beyond, you can create your own custom profiles. So you can just go ahead and click on the plus sign right here, and you can say that my virtual machine profile would be XYZ, whatever you want to call it. Let's call it vExpress large. And you can basically go ahead and enable this for all the policies if you want to, or just keep it on a specific policy, which is the default policy. And then you have a choice of saying that this vExpress large is actually an 8 CPU VM with specific amount of memory allocation and disk space allocation. Or if you already are running the environment and you want to go ahead and select an existing large VM as a model, you can click on Populate Metrics From and select an existing virtual machine from the list of VMs that you have in that particular vRops instance. So basically, net-net, it helps you define your own profile. So whether you are a service provider or you are an enterprise organization and you have a catalog of some sort in terms of offerings, in terms of how many, I have 3 different sizes of VMs which I offer to business, 2 CPUs, 16 GB RAM, 4 CPU, 32 GB RAM, 8 CPU, 64 GB RAM, then you can basically clearly come here and say that, oh, with the capacity which I have, I can do 32 large, I can do 64 medium, and maybe I can do 96 small virtual machines. And hence, to marry this data with the demand data which you're getting from business becomes much more simpler and easier, and basically you're able to determine that when will you run out of capacity or how much more you can shove in the existing infrastructure which you have. Right? So that's about capacity remaining. I would take a break here and ask Simon if you see any questions on the chat window.
Everybody's listening. I think everybody's just enjoying the content and no questions so far, mate, so carry on.
All right, fantastic. So yeah, just to remind everyone, if you have a question, just put it on the chat window, and I'll be happy to answer that as we are setting up the context. So that's about demand and allocation for CPU. Similarly, you can have it for memory, you can have it for disk space, and so on and so forth. Remember, if you have enabled disk I/O and network I/O, then you can also get capacity numbers from the perspective of remaining virtual machines based on disk I/O and network I/O. Now, while this sounds fascinating, I would definitely not recommend that because of the fact that vRops has limited visibility into what kind of network capabilities and storage I/O capabilities you have from your SAN and WAN, or your LAN perspective. So that's something which is limited, and we've discussed about it before as well. So it's always good to look at 3 things: CPU, memory, and disk. And those 3 will be able to give you a complete or a holistic picture from a perspective of how many virtual machines you can put in. Yes, disk I/O and network I/O is important. However, that might not be the calculation which you want to depend on from a vRops capacity engine perspective. You might want to look at storage or the space as one of the requirement, and then you know that as you grow storage, you get more performance from a perspective of IOPS. And you also know that if you grow storage and add more controllers, you get more performance from a throughput perspective or from a perspective of front-end calls of your storage controller, etc. I don't want to go there today, but yeah, these are the options that you have. So coming back to the other stuff, which is the time remaining, right? I think there are a couple of questions there, Simon. Let me just pull them up myself. Okay, so there's a question that says, can CPU buffer, by Sawab Ahmed, can CPU buffers be used for HA, or do we need to have separate buffers for HA? The answer is that the CPU buffers and the HA buffers are two different things. So while you can set CPU buffers, you can also set HA buffers separately. You don't really have to set up together in the CPU buffers. When you go into the policy live demo, I will show you where are the options to select those things. The second question, which is from Naveen, can we remove disk completely out of capacity? Remaining analysis. Yes, you can, and in some cases it might make sense as well. So when I go into the policy again, I'll show you where to uncheck those options so that you don't look at it at all. There's a question about, okay, let me just scroll down. I'm trying to do multiple things here. From Leo. Leo is asking if, for a logical example, to explain the difference between allocation and demand. Fantastic. Okay, let me just think about it. All right. So a logical explanation would be that you have, let's say, 10 family members, and for those 10 family members, you've already you bought pizzas, right? And you've already decided that each family member will get 3 slices of the pizza, right? And that's your allocation. You've already decided how much. The second option is that these 10 family members are different in age group. So there are kids and there are adults, and you know that kids have a lesser appetite and they are only asking for 1 slice, while the adults might ask for 4 slices. At the end of the day, you need to make sure that everybody is satisfied with the amount of pizza you have. And hence, that is more of a demand-based capacity planning as compared to the original one where you decided that it will be 3 per head, no matter if there is more hunger in those adults or not. So that's an example which might settle it. I hope that was useful. I don't know. Does it make sense, Simon?
Yeah, I think that's pretty good. If you need more clarity on that, you can touch base with us later. Maybe in the Q&A session or email us after the session.
Yep. So there's a question by Roshan. He's asking if there's any limitation to creating the number of profiles, or we can create as many as we want. That's a great question. I've not tested Roshan, so I don't know what is the upper limit. But I believe if you look at a service catalog of an organization, they might not have more than 10 options. But if they do, I believe it's easy to create 10 or more. These are just configurations or XMLs which are saved in vROps. They're not resource consuming per se. So I don't believe that you will hit a limit for creating these. Okay, so yeah, I just wanted to clear out those questions, Simon. I'm sorry I jumped in right now, but yeah, it'll be good as I build the context around capacity remaining. All right. Okay, it looks like Simon cannot see the questions. Okay. All right, don't worry about it. I'll take care of them as we move forward. All right, so moving forward, the second option, apart from capacity remaining, is time remaining. Now, time remaining is where it takes it to the next level. And here is where it basically not only looks at what is left from a capacity standpoint, it also looks at the trend in the way in which you have been deploying or adding new virtual machines in your environment. So that's where trending and forecasting comes into picture for vROps, right? That's where it looks at how you have been adding virtual machines in your environment, and it gives you a forecast in terms of when you will run out of capacity or you will run out of an individual resource which is building up the capacity for you. This begins on, and if you look at my screen, and Simon, can you hear me? I just want to confirm that I'm still audible to everyone.
Yes, you are, absolutely.
Okay, fantastic. So if you look at the screen here, you can see that I have 100% time remaining. Now, it basically means that I've not been adding much in my environment for a long time. And I can tell you that because this is a lab environment, and my capacity numbers will not be anywhere near to a real-time production environment. Because in a production environment, you would see inflow of virtual machines, if not every day, but at least every 2 weeks or every month, depending upon what kind of an organization you are. Now, over here, you can see that I have a greater than 1 year remaining for everything, whether it's CPU, whether it's memory, or whether it's disk. And everything says that I have greater than 1 year remaining. And the simple reason behind that is that if you look at my breakup of adding resources, it's just been flat. There's no addition of resources on a day in, day out basis. And what vRops does is it looks at 12 weeks worth of data, and based on that, it looks at how you have been deploying resources. So let's say today is January 1st, and you started your infrastructure, started your vRops, and you basically attached it to an existing vCenter where you have 500 virtual machines. Then this number of capacity or time remaining would not be the ideal number to look at, because vRops will think that you will deploy 500 virtual machines every single day, and that's how trending works for any software for that matter. But if you look at 12 weeks later, you might have a more, a curve or a curve moving above, which is more linear in terms of how you have been adding resources over and above those 500 virtual machines. So this is more to look at from a day in, day out perspective from a capacity standpoint. So that's very important. When you look at time remaining, you have to be cognizant of the fact that if you're doing bulk imports into the system, then the trending will be based on those bulk imports, which will definitely go haywire. And because of those trending going haywire, it will basically have a forecast which might be crazy in terms of how much you want to add. There are algorithms in place which basically try to go ahead and narrow down those steeps or those climbs which happens due to bulk imports. However, you will still see a number which might say that you're running out of resources soon. So in a steady state environment, this is where you want to look at and understand how your capacity growth is happening, and based on that, take decisions from a time remaining perspective. So that's about capacity remaining and time remaining. Okay, so you can see here in this graph over here, I have my 12 weeks data where I have my pink bar showing in terms of how much I'm using. And then I have a gray line which tells me this is right now for memory. And then you can see my trend line or my forecast line for is pretty much straight. It's just saying that you're not doing anything. In a production environment, this would be linear, definitely. And you would see that it'll be growing up and up because of the fact that you'll be adding resources day in, day out, or adding virtual machines day in, day out. And that's how you come to know about how much time is remaining. While we look at the policy, we'll basically go ahead and look at how you can do the right settings in your policy to help get the approximate number which can help you plan ahead from a perspective of when you will be running out of capacity. Okay, so I think that covers the portion of capacity remaining and time remaining. And now it's time to see how we can help vExpress.inc, the organization which has different environments, and based on that, they are looking at different configurations within vROps which can help them generate the right capacity numbers. So, Simon, just asking you if we are good on time at this moment.
At the moment, we have, I would say we've got about another 15 minutes before we need to hit the Q&A.
Okay, fantastic. I think that's less, but we'll try to see how much I can speed up. Okay. Okay. All right. So let us quickly look at the scenarios, right? The scenarios are on the deck here, and I want to make sure that I am clear on each of these scenarios as we move forward. So you can see that I have a Tier 1 environment, which basically runs 20% of the applications. However, it's business critical to them. And what this translates to is that if I'm running a business critical environment, then I would definitely not look at something like overcommitment, right? Something which basically introduces the risk of having contention. While I say that for my Tier 1 apps, Tier 1 apps doesn't mean always that they are the SAPs or the Oracle databases or the critical ones which basically are sensitive to latency. Yes, all these applications which I named and many more are sensitive to contention. However, there might be applications which are not sensitive to contention but still are business critical for an organization, right? It could be a web server, it could be a website of the organization itself, of the Express. And if it goes down, it's basically impacting their business, right? It's impacting their value in front of their customers. Hence, it's important that you categorize these carefully when you sit with your customers or sit within your organization with your business, so that you have the right set of applications identified for Tier 1, and based on that, you do capacity planning for those particular tier or that particular tier. Now, within Tier 1, you would have to focus on not overcommitting because of the fact that you are not worried about the expense of the infrastructure, but you're more worried about the performance as well as the availability of your environment, right? And when we basically move into the next session, which I believe Ivan will be leading from our side, from the April session perspective, he will talk about contention, and he'll talk about more in terms of how availability and performance, or how basically capacity and availability impact performance. And that's where we'll peel the onion and give you more details in terms of how it can do it on a day-to-day basis and how it can basically impact performance on a day-to-day basis. So keeping that in mind, Tier 1 will have no performance impact because we will do no overcommitment, and that's our expectation to begin with. The second one is Tier 2, and this environment runs all the applications and everything else, right? So this is an environment where basically I would not worry about no overcommitment. I'll do some overcommitment, but probably want to limit myself in terms of overcommitting as well, because remember, these are still production applications. And the third environment is the Tier 3 environment, right? Now, if you circle back in what I showed you from an allocation and demand perspective, you can actually fit in the boxes pretty easily. So if I was the one creating a policy for Tier 1, I can clearly see that I'm not worried about the demand primarily for capacity. I'm worried about allocation because I don't want any overcommitment. So if I was the one creating a Tier 1 policy, I would probably create it with just allocation. And we'll say that my allocation ratios are 1:1 because I don't want to go ahead and overcommit at all. The second scenario is Tier 2. Now here, I want to overcommit, but I really don't know what my limit is because I don't want to face performance issues. And this is where you can take the decision of having allocation-based policy, however, having a second line of defense by adding the demand into picture as well. So you will basically go ahead and enable both allocation and demand at the same time, and then wait for the results. The results will basically tell you what is the least common or lowest common, and you can take your decisions accordingly. So just for example, you can set up 4:1 as the policy for overcommitment on CPU, for instance, while you also enable demand-based policy or demand-based calculations of capacity. So, and then you can compare that which one is giving you the lesser result. And you can push the envelope till the time you meet your allocation ratios or you do not cross your allocation ratios. So that's how you set this one up. The last one is tier 3, and this is test and dev, right? And if it's test and dev, you don't really worry about performance here. I'm not saying it's applicable to every single organization out there, but for vExpress, that's the case. They're looking at consolidation, and they're not looking at giving the best performance to their test and dev environments. In this case, you can actually choose the third option, or create a new policy which will basically only work on the basis of demand, and hence you are making sure that you can be as aggressive as possible if you want to. Now, in some cases, this might turn the tide for you because you might be demanding a lot in case of test and dev. So if you know your environment, and keep me honest, Simon, on that, but what I've seen is some people go with the demand-based policy for test and dev, and the demand of those test and dev environments is too heavy sometimes. And if that's the case, they're not able to do a lot of consolidation because of the fact that vRops tells them that, you're running out of resources or capacity because your demand is too high.
Yeah, that's quite common in some environments. And in some cases, I've come across environments where in the ideal world, you'd expect separation between perhaps development or test or Q&A against production, but that doesn't always happen. So you kind of get mixed results there. So these are things definitely to bear in mind, that you're absolutely certain of where these different types of workloads are present in your environment, and they may be on the same clusters, and there may not be resource pools as well. But I don't want to get too heavy into that today.
Yep, absolutely. So taking that into consideration for this particular use case, for this organization, we came up to a conclusion that we need 3 custom groups and we need a corresponding custom policy. So what I've done is I've already created these custom groups for tier 1 and tier 3 because I already have, I thought I'd save some time on that, but I'll do a demonstration of creating that custom group for tier 2 so that you can have a look in terms of how it's created. And then we'll quickly create policies for each of these groups and select the settings based on what we have discussed so far and what we think is the right resolution or capacity policy for vExpress. So let me jump into the demo screen again. All right. So let me just take you to the home page and start from there because it's always good to know where you are in the tool. So from the home page, you would first go ahead and create the custom groups. So you can see that I have environment here, and from environment, I can go into custom groups, and you're already in the groups page right now. And within the groups page, you can see that I have a T1G and a T3G group, which is the tier 1 group and the tier 3 group. Now, to be honest, I don't have any virtual machines or any infrastructure or environment under it because I just have a single cluster. And while Rawlinson is awesome, he didn't give me access to the vCenter so that I can create more resource pools, etc. But I can always go ahead and create a tier 2 group now and attach it to the existing cluster which I have. So here I am, clicking on the plus sign, creating a T3G, which is my T3 group. And since I have different environments or tiers, I want to create an environment type of group. And you can choose any of those options if you want to, but I like doing environment, especially for different tiers. And then I can have a policy. So currently I don't have a policy in the system for my group, so I will just leave it blank and it will automatically attach to the default policy. And then later on I can tag the policy to this particular group. This is important so that you can keep the group membership up to date so that let's say you're creating a group of which belongs to a cluster. That's my group type, and I'm keeping the group membership up to date. Basically means that if I add a new VM in this cluster or in this group or the cluster which this group is monitoring or a part of, then you would basically have that object added into this group automatically. So it's more of keeping everything up to date from a group standpoint. So if you add new VMs, same policy which we are trying to apply to this tier 2 group applies to those new VMs as well. And then you can basically go ahead and say, what do you want to add into this group, or what is the object type on the basis of which you want to create this group? So in my case, it is actually the cluster, because the one cluster which I showed you earlier is the cluster which I want to use and put that in this particular group, right? And that will make sure that any virtual machine which comes into that cluster is a part of that group which I'm creating. Okay, so object name contains okay, I'll just quickly fetch that name from here.
While Sunny's doing that, just want to reiterate, at the moment I can't see the questions, guys, so if you want to send me your questions privately, then I can interrupt Sunny while he's finishing off the presentation. We should be wrapping up the demo in about 5 or 10 to allow for some Q&A time, but we're mindful of the time. We know everybody's busy.
Yep. Thanks for holding that, Simon. Okay, my bad. Let me just check. Let me just add the virtual machines. For some reason, it's not populating my cluster name. Object name contains.
It's the curse of the live demo, I think.
Oh, there you go.
There we go.
There you go. Yeah, that's what happens, right? Okay, so that's my cluster, which is added to this particular group. And then I do have the option to make sure that the objects which I always want to include within that particular cluster. So you can basically include all the hosts, or you can exclude them depending upon what kind of a group you're trying to create, right? In this case, it's important that once you include or exclude stuff, you can use different permutations and combinations. So I can also say that include all the objects, let's say virtual machines, which are descendant of a particular cluster, which is this one, and hence it will include all the VMs. Similarly, it will include all the data stores, etc., if I have to. So in this case, just for fun, let's just go ahead and select everything which is in this cluster, and I can add over here. I can further go down, and if I want, I can add the VMs as well, and so on and so forth. So you can do grouping with various different permutations and combinations within vRops. So I'm just using this as an example to do this, and let's just go ahead and preview, and you can see that all this is what will be a part of this particular policy or a group, which I'll later on apply to a policy. So, okay, it looks like I've created D2G. Click on OK. And now you can see that I have a group here, which is my new group, and that is within 5 minutes, we'll start collecting data on it, and I'll see the health risk and efficiency associated to that particular group as well. Now, once you have the group, you quickly jump into the policy. So you go into administration and go into policies. And you can see that I have a single policy, and I would not go into details of what the single policy is, because if you want to know that, you can go into the previous session, which we did. But what I'll do is I'll jump into the policy library, and within the policy library, I can basically go ahead and add a new policy. So I can quickly say, click on the plus sign and say, I want to go ahead and do a new policy, and I will get into the new policy wizard. Say it has to be a tier 1 policy, and I can give it a description. This is a tier 1 policy for vExpress or whatever you want to call it. And then it starts with the default policy. So this is what Simon was talking about. Whenever you create a new policy, or even if you want to create your own default policy, you start with a policy, and that should be the existing default policy, which is given out of the box from the system, so that it makes it easier for you to make changes and do not change the one which is given by VMware out of the box, right? Then you can go ahead and say what should be my base, or where should I start from in terms of settings, and you can select the base policy and so on and so forth. I will not go through all the options right now, but I will basically go ahead and just create this or duplicate the policy based on based on what I said earlier, based on my default policy. So this is a T1P policy or tier 1 policy. I'll associate it with the tier 1 group right over here and click on save. All right, so that's where I created one more policy in the system, and you can see that it's under the tree of my default policy. So anything which changes in default policy automatically changes in this policy as well, based on how you configure it. Then I can basically go ahead and quickly create a couple of more policies. One is for T2, and apply it directly to the T2 group, which is this one. Click on save, and I have my tier 2 policy. And then similarly, I can create a tier 3 policy. So T3P, and I apply this to my tier 3 group. Click on save. Now, right now we have done two things, right? We've done created the groups and then associated those groups to specific policies over here, right? And you can see that clearly. If you click on any of these policies, you can see that it's attached to one group. And as I said before, my tier 1 and tier 3 are empty. There's no objects under it. And if I click on my tier 2, you can see that I have one group associated which has 12 objects inside that particular group, right? Now, if you remember, we had different policy settings which we were thinking of from a capacity and time remaining perspective. So for tier 1, no overcommitment. So you just go into your tier 1 policy, edit it, and then you can set up the policy for various different object or container type, right? And we were looking at cluster as the container. So basically, you have to pull in the cluster object over here. So you can either do all object types, or you can select a particular object over here, right? So let me just scroll down, and from vCenter adapter, select cluster compute resource and add it. Once I add it, I can do modifications to that settings of the cluster compute policy or cluster compute resource object or container and change the capacity numbers, which I was talking about before. So since I'm doing this for my tier 1, I would basically go ahead and change the policy to not have or to have only allocation-based capacity calculations, which is no overcommitment at all and not demand-based, right? So finally, I'm on the capacity screen. And within the capacity screen, I need to look at capacity remaining over here, that section. And I can just click on the drop-down and unlock the button, which is this lock button. Just click on it, unlock it. And after unlocking it, you can make changes, right? So if you see over here, I have various different options, right? There's things like capacity buffer, which I was talking about. So you can see that in this case, I want to go with CPU allocation. So I'll uncheck demand right over here, right? I don't want disk space. And somebody was asking that question. If you don't want disk space, what do? Just uncheck all the other options. So I just uncheck disk space. I don't want to worry about capacity calculations based on disk space. I want to go with memory consumed and, memory allocation and not consumed or demand. So I uncheck everything else. And then I say that I want to put a buffer of 10% for memory. If I want, I can increase this to whatever I want. And then even for CPU, I want a buffer of 10%, which is good for my tier 1 environment. And then I have the option of overcommit, right? And here you can see I can say, yes, I want to by ratio or by percentage. Now, it's pretty simple. If you say 0%, then you're not overcommitting at all. So if you have 100 terabyte of memory, then you can only use 100 terabyte of memory. And as soon as you hit that number for allocating 100 terabyte of memory on your VMs, the vRops capacity calculations will say that you're out of memory now. You need to buy more. If you want, you can overcommit. And in that case, you will, let's say, put a number 10, which basically means that it's 10% above 100, which is 110 terabyte in that case, right? So remember that. I've seen people typing 110 here, thinking that this will give them 10% extra, but that's actually double or more than double. So that's important to remember. Now remember, this is our tier 1 policy, so we will not overcommit memory at all. From a CPU standpoint, I don't want to overcommit CPU as well, so my overcommitment ratio would be 1%, 1:1. Basically means that I'm not overcommitting anything from a CPU and memory standpoint. And then comes the part of HA. So here is where you can say that I want to use HA buffers or I don't want to use HA buffers, right? So here's where you can check that option. So I check this option. It's by default checked in this case. And then I can use the other options around stress and capacity and time remaining scores from a committed project's perspective. So this is which is what Simon explained before. If you are committing projects within your system, then these calculations can also or will also change in terms of how much capacity is remaining from a CPU, memory, and disk perspective because you've committed something to the system. And if you really want that calculation to happen and remove that particular extra capacity which you've committed from the results, then you have to come and check this option, which is checked by default, but yeah, I mean, you can uncheck it if you don't want to do that. And then, of course, it talks about provisioning time buffer, which is 30 days. So this assumes that if you have 30 days remaining from a time remaining capacity calculations perspective, it will tell you that you have 0 remaining because you already have a buffer of 30 days over here. So another example is that if you have 100 days worth of time remaining, then with 30 days buffer over here, you will see 70 days remaining inside the calculations. So it basically buffers out or removes those many days and gives you an alarm in terms of telling you that you're already out of capacity while you still have some buffer. And this buffer is pretty much the procurement time period which a customer takes to get new resources into their existing environment. So to be honest, if I talk about Asia, that number is close to 60 at every customer place. If I go into a remote place in Asia, then that number goes to 90 or even 120, depending upon how quickly the customers can get new resources. So to be honest, that's all you need to set up from a capacity and time remaining standpoint. And once you set this up based on your customers or your own requirement, just make sure that you lock the button and you don't lock the button, but just make sure that you save these settings. And once you save these settings, they will basically apply to that tier 1 group which you created. And the capacity calculations for that tier 1 group will now consider that you're not overcommitting anything, and hence your results would be equivalent. Let's quickly do that for tier 2 as well. So I'll just go ahead and edit this, and probably I'll end it after doing it for tier 2. So within tier 2, I can just go ahead and go into, again, pulling in the cluster compute resource and add it. And I can do it for hosts, for virtual, for any container, not for a virtual machine, but for any container for that matter, right? So if your group has that particular container, whether it's a host or a cluster, then all these settings will apply to that particular group or the containers within that particular group, right? So similarly, I can create another one for my tier 2 environment. And remember, in the tier 2 environment, we decided that we will go with both capacity, both demand and allocation. And in that case, I will just uncheck consumed, go with memory allocation, memory demand. So I check these 4 options. I also want to do it for disk space on the basis of allocation, right? In this case, so I'll leave that on. And then I really don't want to buffer anything from a memory perspective. I just want to use whatever I have, and I don't want to buffer anything from a CPU perspective as well. So my buffers are 0. I do want to make sure that I buffer for HA, so I keep this option checked right over here. I want to make sure that I buffer this space on my data stores for 10%, which I keep it on right over here. Well, I don't want to overcommit for my storage or from my virtual machines. I do want to do a little bit of an overcommitment for my memory, so I do 10% overcommit. While for CPU, I have the latest Gen 9 servers from HP, and hence I want to go ahead and go to 8:1. Now remember, since you are selecting both CPU demand and allocation, whatever is the most constrained, you will get the result of capacity remaining and time remaining based on that. Which basically means that at any given point of time, you have a defense line that you would never go ahead and commit or overcommit beyond what your cluster can basically run in your environment without impacting performance. And the second option is that even if you have, let's say, VMs remaining when you have reached 8:1, since you have selected 8:1 as a defense line and your policy says that you don't go beyond that overcommitment ratios because you don't want too many eggs in a basket, then you basically stop right there. And once you reach that ratio, you either add a new cluster or you add nodes to the existing cluster so that you can basically keep provisioning new resources on new virtual machines if you have to. All right, so I'll just go ahead and click on Save, and that will create my Tier 2 policy and change it from a capacity standpoint. So now you can see that I have 3 different policies, and each of these policies have different configurations which meet the requirements of vExpress. And I can basically go ahead and also look at these results based on what I've configured. So I can go into custom groups, and I can, let's say, go into Tier 2. And within Tier 2, I can go ahead and go to analysis and look at capacity remaining. And it will give me results based on what I selected back there, right? So you can see that I have these objects within this particular policy, only these specific objects, and based on that, I have the count percentage of each of these particular objects, right? If I apply it to a specific cluster, that particular policy, right? In that case, you will see the settings which I showed you before from a CPU, memory, and this perspective. So if I go back to my environment and go to vSphere host and clusters and select the cluster in question, then if I apply the policy directly on this cluster instead of a particular group, then I would see the changes right over here, which we were discussing before under capacity remaining. Okay, so I think that was a quick demo of what we were talking about. And I would probably just go ahead and ask Simon if he wants to add anything to that, because we don't have much remaining on the clock.
Yeah, I think we'll probably have. So I think I don't think I've got anything to add there. Yeah, it was really great. I don't know if we've got any questions. I can't see that panel. I don't know if you can see any, Sunny.
Yeah. I don't see a question at this moment on the panel, but if anybody has a question, we have a couple of minutes before we end this, and feel free to ask that right now if you have one. And I can basically, if you want, unmute all, or maybe you can unmute yourself by pressing *6 if you have to.
While we're waiting potentially for questions, the next session will be with Ewan. Do you want to talk a little bit more about that, Sunny, or does Ewan want to talk about it?
I'll try to unmute Ewan. Okay, Ewan, if you're still on the line, then you're unmuted, and you want to go ahead and give us a dope into your next session? Or maybe I can do it while...
Yeah.
Oh,
we will be talking about the 50 Shades of Contention, I guess. I'm happy to. I think I have just shared the training deck. We conducted a training for our top partners in Bali last week, and so we built that deck. It is as usual, fresh from the oven. So it's assuming that you know vRops, and we build upon that. I don't know whether I was allowed to share, but anyway, it's just technical stuff, so just go ahead and use it. And that is actually a whole day material, so we can pick any one you want, and we can compress it to an hour. It's fine with me.
Yep, absolutely. So the next session, and Ivan clearly missed what the session would be about. It's basically about performance and capacity management with a different perspective, a perspective of contention. And that's what we are going to talk about. And we'll partner up and probably do an hour and a half or so. And we'll try to give you a lot of goodies on that session from dashboard perspective, so that you can use or take some of those learnings and use them immediately in your environment, and start building on those contention-based performance and capacity management numbers. Okay, so I do have a question here, and I think we can take that as a last question. That's from Leo. He wants to see how to create a custom group. Okay, so Leo, we would definitely post this recording on our blogs, and you would basically see that data once again, which I followed through earlier, of creating a custom group. So I really don't want to run through that exercise once again, but I would appreciate if you can have a look at that video, and you would basically get a full dope in terms of what all we did. And just to highlight, you would see that video recording up there on our blogs, and you can get the blog links from this page right over here. Awesome. Right. Okay, so I don't see any other questions right now, so I think we are good to go, Simon. I want to thank you, everyone who joined in, and I want to thank you, Simon and Ivan, for bearing me for so long.
No, thanks very much, Sunny. You did a great job today. It's not an easy topic to explain in a short period of time, and I think in many cases because of the terminology and all of the, it's a complex thing with all of the check boxes. I think everybody can sit down and just pick their way through it slowly. In some cases, getting this fine-tuned is a labor of love, so I'll leave it at that. Thanks very much, Sunny. That was great.
Thank you, everyone. Thanks, Simon. Have a good day.
Yep. Thank you.